Hello friend, today I'm going to discuss on covariance and correlation. Important thing in data science. Actually, it helps to identify the relation between different variables. Let's have a look. The core objective of this covariance and correlation is actually, are these two variables related to each other? So in data science, machine learning and statistics, answering this single question is the foundation of finding patterns, making predictions, and building intelligent models. So very crucial thing. So let's start with the covariance. What is covariance? Covariance tells us the direction of relationship. Do two variables move together or do they move in opposite direction? Basically, there are two covariance, positive covariance and negative covariance. Also, zero covariance also present. So let's start with positive covariance. If one variable increases, the other variable also increases. That means they move in the same direction. It's called positive covariance. Like study hours, if you increase, marks also increase. Right? Now coming to the negative covariance. If one variable increase, the other variable decrease. That means they move opposite directions. Like hours of exercise, if you increase, then body weight obviously decrease. It's called a negative covariance. So let me visualize the positive and negative covariance. The left side graph you can see the is showing the positive covariance. It's a scatter plot, and you can clearly see this moving from left to right upward. Okay, and for the negative covariance, it's downward. And if you see the in the plot, it's scattered. Okay, you cannot clearly view the any direction. In that case, it's near zero or no relation. This kind of thing you can say. That means no relation over there. If no particular direction, you can see. So let me come into the limitation. From the graph relation, you clearly see the relation, but you cannot understand how tight or strong the relationship is. Because if you calculate the raw number, I mean, if you find out the correlation, sorry, covariance of a two variable, you cannot understand how strongly they related. Let me the problem like the actual numerical value of covariance depends on entirely on the unit or scale of the data being measured. Like suppose you salary measure in rupee versus dollars, the mathematically covariance will change drastically. That means if you find out the covariance of the salary in rupees, it will give you like 6,670, and if you same amount in dollar, if you convert it to dollar, then it will give you like 6.67. So just seeing this number, actually you cannot identify the relationship between two variables, right? because there is no fixed range. If your salary increase, then also covariance also increase. I want to mean that you cannot tell that if small change of one variable, how the how it behave the other variable. It strongly behave or slowly, okay, or weak, okay. So for that, actually we need the correlation. Actually, correlation solves the scale problem because it standardizes the version of the covariance. That version of the covariance. So unlike covariance, which only gives a direction, correlation gives us both. It tells us the move together and exactly how strongly they are linked. It is completely independent of scale of the original data. As I mentioned, it actually standardizes the uh, value of the covariance and it provides the fixed range like from -2 to +1. If plus value near to 1 and positive 1, so perfect positive relationship. If 0, no meaningful relationship, and if it was a -1, then perfect negative relationship. How it looks? Actually, it looks same like covariance. You can see the strong positive, it's a weak positive, it's more scattered, loose, okay, loosely coupled. And strong wave tightly coupled. Here you can haphazard, no direction you can identify. So no correlation. This is a weak negative. This is a strong negative, and you can see it is a non-linear. So here also I explain the positive, a perfect upward line, negative, a perfect downward line, zero random scatter like this, no correlation. Okay. Now just the comparison table, covariance versus correlation. Covariance show direction only. Correlation show direction plus 10. Covariance scale dependent. That means affected by a unit like dollar and rupees, right? Correlation scale independent because it standardizes the value. Covariance hard to interpret raw number definitely because as it is scale dependent, it is hard to understand. And correlation easy to interpret instantly because it's a range value. Covariance range is not fixed, and here correlation strictly bounded. Here the raw connection and normalized connection. Okay, why it is important? Yeah, definitely it's a feature selection. When you planning to create any machine learning model, the feature selection is a very important thing. For example, suppose you want to going to predict the house price. That means house prediction model. So you have to find out which variable actually affect the price of the house, like room size, location, okay, and number of rooms, okay, so and many more. So you need to identify which are the key variable affect the size, price of the home. So this is the for that very helpful. Now detect multi-collinearity and it's crucial in linear regression. highly correlated independent variables confuse the model and make it unstable. So detect the multi-coding is a it helps. Recommendation system used to find similar user behavior. For example, users who watch action movie also tend to watch science fiction. Understand relationship, yeah, definitely. Stock market analysis. I will explain in later in detail as well. So for now, just know the features. Okay. So I will show you how covariance step by step calculated. Also correlation. I'll in later yeah, sorry, in other document I have write down all these things. So that's why I'm not explaining this slide now. Just see the equation for covariance calculation. This is the equation. Okay, this is the summation of origin value minus mean y minus mean divided by number of elements. The average of the product of deviation from the mean. And correlation equation is covariance divided by product of standard deviation of x and y. This is the equation of correlation. Let me show you how mathematically calculated it. So covariance asks, do they move together? And correlation asks, how strongly do they move together? This is actually the mental model. Let's memorize this thing. Let's have a look how we can mathematically calculate correlation and covariance. First, we have to calculate the covariance, then correlation. So this is our sample data, study hours and marks. Okay, study hour 1, marks 42, 53, 60. Okay, so goal, do study hours and marks move together strongly? The first step is we find out the mean of x. So sum hours 1, 2, 3 by 3 also 2. So x column is study hours and marks column is y. Okay, so summing it up and divided by the same for the marks. So we have calculated the average or mean of the x. That is 2. Similarly, the mean of y is 50. Okay. Now subtract mean for x. So x, my original value plus mean. That is the mean of x was 2. So 1 minus 2 is minus 1. 2 minus 2 is 0. 3 minus 2 is 1. Okay. Actually, minus 2, minus 2, minus 2, like this. Okay. Similar way, we have to calculate the y mean. We have to just subtract 50 because the mean of the y was 50. So 40 minus 50 minus 10, 0, 10, right? Now we have to find the standard deviation. For x, we have to calculate the standard deviation. So mean was x x minus mean what? Minus 1, 0, 1. Yeah, this one. We have to first square the all the values. Like we get this similar, and then we have to add all the values. Sorry, that is 2. Now divide by the total value. I mean find the average. 2 by 3, so 0.67. Now we have to take square root of 0.67, that is 0.8. Now this is the standard deviation of x. Actually, this is a way to how to calculate the standard deviation. In the previous learning video, I already shown how to calculate standard deviation. Okay, so we have to take the average of the x minus mean square. Take the average of the x minus mean square, and then need to find the square root. So then the value will be the standard deviation of x. Similarly, we have to find the standard deviation of y. Similar way to square the value, take the average, find the square root. It's 8.1c. The standard deviation of y is 8.1c. Okay. Now we are calculating the covariance calculation. In the previous step, we got the x minus mean this, y minus mean also this. So we have to multiply these two things. This is the thing, and x minus mean multiply y minus mean. We got this column. Now we have to add this. We also again we have to find the average. So this is the covariance. How we have calculated the covariance? So x minus mean multiply y minus mean divided by sorry, I need to take the summation and average. So this is the actually covariance. So positive means hours and marks increase together. Covariance positive means increase together. So positive covariance. Now we have to calculate the correlation. As per our equation, covariance divided by standard deviation of x multiply standard deviation of y. We have already calculated these two. So we need to put the values. Covariance 6.67 and multiply these two things, and we finally get this thing 6.69. Now we have to divide the covariance by the multiplication of the standard deviation. That is around 1. That means positive 1. That means a very strong positive relationship between hours and marks, study hours and marks. So this is the way how we calculate the covariance and correlation, and how it helps to find the relationship between two feature, you can say, of a data set. Thank you. Well, in the next learning video, we'll come up with a new study material to make it more fruitful and interesting. Thank you for watching.